Hi, and welcome to the AWS Nonprofit Office Hours. My name is Alex Chinoji. I'm a technical program manager. Here with me, we have Avid Rabikin. He's a senior solutions architect, storage specialist. He's going to talk about AWS Backup. Hi, Avid, please take it away.
Thank you. About a year or two, I believe now, a new service offering, managed service called AWS Backup. And it provides a fully managed policy-based backup service that makes it easy to centrally manage and automate your backup across your AWS services. The current supported services are on the right-hand side, which is Amazon EBS, EFS, which is Elastic File System, RDS, which is our managed database, DynamoDB, Storage Gateway, and Amazon EC2. So what are the use cases regarding cloud native backups, right? Obviously, protecting your critical data across those supported services is paramount and important. Compliance, showing that, yes, I've backed up my environment is also very important, as well as, disaster recovery, right? Reduce that risk of downtime to your business, right? How does AWS Backup work? With your supported services, what you can do is through AWS Backup, through the console, create a backup plan that has different varying levels of retention based on what your backup policy is. Then what AWS Backup does is it enacts those backup policies on your services and then creates a wrapper around each one of those backups. And based on your permission set, right, that's on the right-hand side, your IAM, which is Identity Access Management, you can specify who can perform backups, who can restore backups, who can delete backups, right? So it gives you that compliance around your backups that you normally wouldn't necessarily have if you were to script it all yourself. Now, on the left-hand side, your SNS and CloudTrail, right? Those enable you to send out notifications and have a central area for your logs to be able to see whether or not your backups have successfully completed or there were failures, right? You can send out automatic emails, whatnot. So it's a nice wrapper around what normally would be a scripting that you would have to do in order to back up these individual services. How does it work? If we double click into the service itself, the majority of the services, and I'll say with the exception of EFS lands on the data plane side, which is on the right side. But for all the other services, EBS, DynamoDB, RDS, they are control plane services. And what that really means, what we're doing under the hood is we're integrating with the APIs that each of those respective services offers already to our customers, right? So in the instance of an EC2 or a VM, you could say that's an instance or VM, however you guys want to call that instance that's running in the AWS cloud. The service provides an API for you to go in the console and click snapshot, and it creates a snapshot. What we're doing under the hood is exactly those same API calls, but what we're doing is we're orchestrating that for you. So from a centralized plan, we're going in and saying, hey, EC2 service, can you take a snapshot of this volume, or can you take a snapshot of this instance that's run? And what that allows us to do is also, with that snapshot, add a wrapper around who can perform operations around that snapshot. So it gives you that extra level of compliance that you normally wouldn't get with the native service itself, right? It creates an AWS backup wrapper around that snapshot. With EFS, we are actually doing data movement. So what we're doing is we're installing a little agent to be able to take that and move the data into the AWS backup vault that I'll show you in the demonstration. You can have multiple vaults for various different things, and we're actually moving that data into the vault. And again, all the other services, we're just orchestrating the automatic snapshot. And I'll show you the demo here shortly and be able to see how this actually works. So AWS Backup supports the following: automated backup and retention management, right? You can set retention policies on how long you need to keep those backups for compliance and who has access to those backup policies, as well as having one place to look for the backup success or failure. Also, for the supported services like EFS, we have the offering to be able to life cycle those backups to colder storage, meaning you've taken a backup, let's say it's several weeks old, you can then set a policy to life cycle that EFS backup to colder storage, which means you pay less. And then, backup encryption is independent of source resource, right? So with EFS, we're actually encrypting the data in the vault itself, so you can rest assured that your data is protected with your keys. So here's at a high level kind of what the AWS Backup currently supports, right? For all of our services that are currently under support, you could create your automatic backup schedules, your automatic retention management, central centralized backup logging, as well as integration with KMS, which is our key management service for backup encryption. Lifecycle to cold storage is currently supported by EFS, and then an item level restore is also supported by EFS as well. Cross-region backup is supported by all services with the exception of DynamoDB. And what that means is you can create a backup in your environment, and as part of the policy, say that I want this backup to not only back up in the local region, but also send a copy of that to my other region. And again, a lot of those use cases have been traditionally been for compliance reasons. Why AWS Backup, right? Simplify that backup operations, right? Get away from running those scripts on a daily basis and have a nice, easy to use console, central area to look and see whether or not you've successfully backed up your environment. Ensure that compliance and security is set, making sure that only the people who have access to be able to delete a snapshot have that access. And even as an example, even an administrator, if they don't have explicit rights to be able to delete a snapshot from the EC2 service, you will not be able to delete it unless you go in and have the proper privileges within AWS Backup to do so. So it's a way for you to ensure that potential malicious actors have less of an ability to do some damage. And then save time and money, right? Reduce that need for the custom solutions and manual process, and centralize the backup operations for improved organization efficiencies. So let me go break out of here and share with you what this looks like. This is the AWS Backup dashboard, right? So you come in, you're faced with manage your backup plans, create an on-demand backup, or restore backup. So we'll start with let's manage a backup plan. Let's create our first backup plan. So when you create a backup plan to start, you can start from an existing plan, create a brand new one from scratch. If you're really good, you can define one that's pre-built using JSON. For the purposes of this demo, let's just build upon a pre-existing plan, right? We offer, daily 35-day retention, pre-built plan, daily, monthly with 1-year retention, daily, weekly, monthly with 5-year retention, and so forth. So we'll just pick up one of these 5-year retention, and we'll just call this backup. We'll just give it a name for now. And what this does is it automatically creates these daily, weekly, monthly backup rules. And you can hit create plan. And what this does is it drops you into the backup plan. So now we are in this backup plan that we just created with these rules that we have set up. And these rules are, again, adjustable. And just wanted to let you know that rules are irrespective of the resources that are assigned. So let's double click real quickly into one of these backup rules. And you could say real quick, say this is my daily backup. It occurs at 5 a.m. And it will start within 8 hours and complete within 7 days. And those are the rules that you set, because for this life cycle, it will not transition to cold storage and expire it within 5 weeks. And the vault that we are going to put it into is the standard default vault. So let's edit it and see what we have. So you can go in here and edit and modify the frequency, and you can even do a custom cron expression that says, hey, I want to do this, let's say for this backup, I want to do this every 5 hours. And that's how you would specify that, every 5 hours. If you're not familiar with cron, you can click the info and it will show you kind of a quick links to, or even Google on how to fill out a cron expression. But you're able to do those types of things. Right now it's set to start at 5 a.m., which is kind of what we had in the default. So, and then you can customize your own backup window as well, or just choose the defaults. Set your expiration policy, and even set which vault you want your backups to be stored in. The next option was whether or not you wanted to copy that to a different region. And again, for compliance reasons, for DR purposes, this became a very popular request, and it was a feature that we launched, I believe, late last year, early this year, to be able to enable our customers to click on, hey, I want to go ahead and copy this backup to US East as part of my backup process. So we didn't really make any changes, so I'll hit cancel. But as you can see, each one of these, when we go in here, has your different schedule for your backups. So once we've set up our backup rules and the retentions that we need on each one of these, now we need to assign resources. To assign a resource, we could just call this backup as well. And we can specify 2 ways to assign a resource. Now, we can go in and say resource ID, and we can go in and say, let's say I know I need to back up some of my EC2 images or VMs. I can go in here and I know that what the resource ID is because I've named them. And let's say I want to back up my Amazon Linux 2 instance. And then I also want to go in and back up my Windows instance as well. I can click add assignment, but what that does is that every time this backup policy runs, it will look for in your account for those two instances and back just those two instances. If you add additional instances, what you'll have to do is come back in here every single time and add the new instance to ensure that it's backed up as part of your backup policy. So a way that we've done to automate some of this and make it so that you don't have to keep coming back every single time to add a new instance, whether it's EC2, whether it's EFS or RDS or DynamoDB. What we've done is we've said assign the resources based on tags. So what we can do is we could say, hey, anytime I have a tag with a key of backup and a value of let's just call this gold, I want to automatically include this as part of my backup plan. So there we go. So now what happens is if we go in here and we go into our EC2 service and we have a couple running instances, I can click in here, click tag, add a new tag called backup and call that gold. And the very next time my backup policy kicks off based on the schedule that I set, it will automatically pick up this resource, this EC2 instance, and automatically back that up. Nothing more to manage other than the key value pair that we've included in here. And you can do things like not just at the instance level, you can come in here and specify, let's say I know that my Windows image instance is an instance that I don't really need to back up the entire VM. I just need to back up the data volume. I can click in here, add the tags individually to the volume itself and say the same thing, backup gold. And now I'm assured that every single time that backup policy runs again, it will automatically pick up this resource to be backed up. And this is the same for all of our resources that are currently supported. If you choose to enable the policy, the automatic assignment based on tag, it will search your account for these tags and it will automatically include them in the next run of the backup. So let's see how manual backup works, right? So we've set a policy, but let's go ahead and let's start a backup. So same thing, resource type, EC2. We're going to choose our Amazon Linux here. We're going to set an expiration policy, right? Let's say I want to delete this after 5 days. We can specify the backup vault that we're going to put this in. And we can also choose a role that we're going to use to back this up, right? And so again, we have certain profiles and security parameters around who can take a backup, who can restore a backup, and who can actually manage those backup resources as well. So I've created an admin role that gives me the proper privileges to take backups and restore backups. So let's go ahead and create this backup. And what happens is it fairly quickly starts to run. Right? And what happens in the background, if you click over here and we go into AMIs, you'll see that we're already pending here. And that's how quickly this Amazon AWS Backup integrates with the EC2 side of the house, where we've already made the API call directly to the EC2 service to say, hey, I want to go ahead and create an image and add this as an AMI. And you can see the volumes here, snapshots in here. You see that they've actually completed the snapshots already as part of that backup. And that's how quickly things happen in the background. What you'll see is the backup job details. It is continuing to run because what AWS Backup does is it reports the EC2 service has created that snapshot. So it's not holding the volumes hostage, if you will. It's not doing that while it's doing the operations. What it does is it creates a point-in-time copy of the volumes as it stood when you created that snapshot. And in the background, it is copying those bits to our S3 service, right? So what AWS Backup is doing is it's reporting that it is still copying in the background. That's as easy as it is to be able to create a backup of your EC2 instance. Now that I have this backup source, right, I've got this AMI, this image that the AWS Backup service has created. A lot of EC2 administrators can come in here and they can click on actions and launch an instance off of this particular backup, right? And what you have to do at that point is you have to remember, okay, for the most compatibility, okay, I know that I think I remember that it was a T2 micro. I think it was part of this VPC, and I'm not sure what subnet it was in. And so there's a little bit of homework that needs to happen before you can restore that. So what we've done with AWS Backup is we've simplified that process. So you can go into here and go into your backup vault and show that, hey, I have this protected recovery point. I can come in here, click on this, and hit restore. And since we've captured that backup, what we've done is we've stored some of the metadata associated with it. So we know that it was a T2 micro instance. We know what VPC it was a part of. We know what subnet it was a part of. And we also know what security groups it was associated with. And we're going to go ahead and restore the original IAM role or identity access role that was associated with that instance as well. And we can go ahead, and since I have my permission set, I can go ahead and restore based on my admin profile that I've created. And just as simply as that, I click restore and it's running. And here I'll switch back over to the EC2 instance, and you can see relatively quickly I've already got an instance running. It's already pending and initializing, and within a few moments, you'll see that it is restored. Now, again, what's happening in the background is that instance is being loaded from S3 down to the EC2 service. EC2 service is making that available almost well ahead of all of the bits that are coming out of S3. So just keep in mind, your performance may be impacted, and that's no different than how it would be from the EC2 service as well. So we're not doing anything strange under the covers, but what we're doing is we're making that instance instantly available to you, or nearly instantly available to you, so you can begin your operation much quicker than having to wait for all of those bits to come down and restore onto the EC2 service. And just as easy as that, my instance is up, and I'm able to do what I need to recover a file, recover the entire instance if that instance was deleted. So yeah, so I think that concludes kind of my demo of what AWS Backup can do from a backup perspective. You can also see, your jobs, what's running, what restore jobs have happened, as well as what copy jobs has also set. So you can see what's going on in your environment. And from the dashboard perspective, you can see, some additional details as to what's going on and how many have failed, what's in process, and what's completed. Another thing here too, you can look at protected resources. These are the source IDs and the various recovery points for each of the instance IDs. So you could say, you know what, this is a backup that I took yesterday, but I need to restore the one that I took this morning during this meeting, and I can go ahead and choose to restore that particular backup point versus the one that I took yesterday. First one, does this service have, right? So it is a free service that we offer. Where you are billed is for the storage that you consume as part of storing those backups. As an example, irrespective of AWS Backup, when you take a snapshot of an EC2 instance, what happens under the hood is you are charged for the storage of that snapshot. And what happens is every subsequent snapshot that you take after that first one, all you are billed is for the incremental change rate between the next snapshot and the previous snapshot. So if you take 100 snapshots, you're not being charged 100% every single time that snapshot is taken. You're charged for the first snapshot 100%, and then for every subsequent snapshot is just the change rate between the previous snapshot. So AWS Backup does exactly the same thing. And what we do is, if you already have through your EC2 administrator, if they've already doing creating snapshots in their environment for their own purposes, all we're doing is we're creating yet another snapshot. And in those cases, all we're tracking is incremental changes within those volumes, and that's all you'll be charged for. So same thing with all of the other services, right? You're only charged for those incremental changes between snapshots. Is there any way to create an indestructible backup at cold state? I mean, something that's not possible to be deleted within the life cycle, even by root accounts. So there is, again, it all comes down to permissioning of how you come in. So let me share my screen one more time and I can kind of demonstrate this. I am an administrator on this account, how I'm logged in. I can come in here and I can do whatever I want. I can run any instance. I can come in and do whatever I want. But if I come in here and go to snapshot, come in here and say, I want to delete this snapshot. This is the level of protection that you get. And it says, hey, you know what? I'm sorry. This snapshot is not able to be deleted. It is managed by AWS Backup, and you can't do it via the EC2 APIs. If you need to delete the snapshot, you need to do it via the backup console. So if you had a separate group that was managing your EC2 images or instances, and a separate group that's managing backup, you wouldn't necessarily grant the right privileges for that EC2 administrator to go into AWS Backup and then click the delete button, right? So that's one way that we're able to go in and make sure that there's compliance around that, who can perform those backups, right? Okay, so similar to the very first question, how much does it cost to for a 1 terabyte backup? When you take, if you don't do anything else, and you have, let's say, a 1 terabyte full of data, and you take that backup, the very first time you'll be charged for the snapshot cost at 100%. Let's say you go a day and you change, let's say 100 megabytes of data is changed, between first day and second day, and you take another snapshot. At that point in time, all you'll be charged for is the first snapshot, because you haven't expired it yet, and the 100 megabytes of change that is included in that second snapshot, and so forth and so forth. And then as you expire the original snapshot, then it trickles down, right? And then you'll pay again for the full size of the snapshot for the second snapshot and all the change rates down the line. So really, it's very cost effective to be able to manage your snapshots this way. You're only being billed for the actual change rate and the data consumption. So what is the difference between backup and snapshots? Great question. Under the hood, there's really no difference between a snapshot and backup. What AWS Backup offers is a policy engine around that snapshot to make sure that nobody could just go ahead and delete a snapshot from your account that is not privileged to do so. So it creates that extra layer of protection for that backup or for that snapshot. But under the hood, it is a snapshot with those underlying services. Can I take a snapshot outside of AWS Backup? Absolutely. We are not in any way preventing you from doing your normal day-to-day operations within those services themselves. What we've done is with those services, when we created AWS Backup and it creates a snapshot within those individual services, we're actually labeling that as such so that you can very quickly identify which snapshots were created by the AWS Backup service. What can I back up using AWS Backup? If you refer back to the services list that I had earlier, current supported services, Amazon EFS, EBS, RDS, DynamoDB, Storage Gateway, Volume, and Amazon EC2. Can I back up my on-premises data? The on-premises data you can with AWS Storage Gateway Volume mode, right? And so what that does is that allows you to create a storage gateway which provides local access to a volume shared via iSCSI, and that volume is backed by AWS or S3. So that is one way that you can back up your on-premises data. We don't go in and install agents on your VMs or anything else and pull that back. It's done via the storage gateway. Is the backup vault S3 or like S3 for disaster recovery purposes? Meaning if AWS has a disaster, will we be able to restore to another region? Another great question. So if you know a little bit about how our snapshots work with our various services, you'll know that when you create a snapshot with, let's as an example, EBS or EC2, that snapshot is stored in EC2, and in the background it is loaded actually to S3, which is provides 11 nines of durability. Very, very durable storage of that data backup set. So chances of something happening, even if an availability security zone goes down, you're able to still recover those data bits. So that's why we introduced the cross-region support to be able to copy your backups to another region. And that was for those companies that needed that extra level of protection to be able to take a copy of that data and completely move it to a different region for DR purposes. We integrate with those services directly, and if those services are storing their backups in S3, that is, we're not changing how we're interacting with those. And again, with EFS, we are actually copying data into our vault, which is then also copied with 11 nines of durability as well. I have an EC2 instance with several EBS volumes. If I back up the EC2 instances, do all volumes get backed up? Can I choose which ones to back up? So yes, when you create an EC2 instance backup, all of the volumes that are attached to that volume are backed up. Automatically, you don't have to do anything. Now, in order for you to choose which volumes are backed up, that's where when I did my demonstration, you can go into an individual volume, add a tag, or go into AWS Backup console and specify that resource to be backed up manually. So that is one way that you can do either all the volumes or very specific volumes that you may have a requirement to do so. It is granular in that instance if you don't need all of it.
My question is, when you're showing us these schedule examples, one of the examples was to start the backup within 8 hours and complete within 7 days. And you also talked about cron scheduling with an example of backup every 5 hours. I'm wondering about if you want to time your backups more precisely, does it take the snapshot at the beginning of that window and then start copying the snapshot to storage sometime within that 8-hour window? Or how does that work?
Yeah, so when you create that schedule, what happens is you create that time window as to what is my time window to be able to create that snapshot. You can't really get more precise than 1 hour. So you could say that I want to take a snapshot, between 3 and 4 p.m. and that is my backup window. What happens is that is then scheduled to the AWS Backup service, and AWS Backup service will say, I'll go ahead and perform this backup, but I can't guarantee a precise point in time when I'm going to back this up. I can guarantee you that I will start between 3 and 4, and that's when that snapshot will occur. Again, keep in mind that when that backup is snapshotted, right, when that snapshot does occur, it is a point in time copy at that point for that service. And even though the data may not be fully loaded onto the back end, onto S3, it will be a point in time copy at that point.
And I have another question from the Chime. Is there any kind of synchronization available? For example, I have 2 virtual machines running a database that need to be backed up at the same time.
Yeah, currently there is no option to say that a set of EC2 instances snapshot at the exact same time. That is not an available option.
Really appreciate you guys joining in, and I hope to see you guys next time. Thank you very much. Thank you, everybody. Have a good day.
Thank you.